Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P0171 and P2187 indicate that the fuel system is too lean, which can lead to performance issues, increased emissions, and potential damage to the engine. DTC P0171 signifies a generic issue in the system, while P2187 focuses on idling conditions. In general, a lean fuel condition means that there is too much air in the fuel-air mixture entering the engine, causing it to operate inefficiently. Key components at risk include the mass airflow MAF sensor, fuel injectors, and the air-fuel AF sensor. The fuel system works by combining fuel and air for combustion. If there's too much air or insufficient fuel, it leads to a lean condition. The area around the intake manifold, fuel injectors, and the MAF sensor are critical inspection points, located close to the engine block and air cleaner. This troubleshooting guide will provide a step-by-step approach to diagnose and remedy the situation associated with these DTCs. The DTCs P0171 and P2187 signal that the vehicle's fuel system is running too lean, indicating a higher air-to-fuel ratio than what is optimal for combustion. Specifically, the MAF sensor and the AF sensor are critical in determining the air and fuel mixture that enters the combustion chamber. A lean fuel mixture can lead not only to performance loss, but can also trigger alarm mechanisms in the vehicle's engine control module, ECM. The MAF sensor is typically located in the air intake duct just before it enters the engine, while the AF sensor is often placed in the exhaust system, providing feedback on the combustion efficiency. Insufficient fuel can stem from a variety of issues such as vacuum leaks, faulty injectors, or incorrect fuel pressure, all of which will be investigated as part of this troubleshooting process. Several factors can lead to the triggering of DTC P0171 and P2187, starting with the presence of aftermarket fuel system components, which may not function optimally with the factory settings. A faulty MAF sensor is a common culprit, as this sensor measures the airflow into the engine and can cause inaccurate fuel trim readings if contaminated or damaged. Additionally, vacuum leaks in the intake system can introduce excess air, further complicating the air-fuel mixture. Fuel pressure issues, such as those associated with the fuel pump or injectors, may also contribute to insufficient fuel delivery to the engine. It is crucial to systematically eliminate each of these possibilities to accurately diagnose and resolve the problem at hand. Symptoms associated with DTC P0171 and P2187 can manifest in various ways, impacting the vehicle's performance. Drivers may experience engine stalling, particularly at idle or low speeds, since the engine struggles to maintain a balanced air-fuel ratio. Poor acceleration is often noted, as a lean condition can hinder the engine's ability to generate power effectively. The check engine light will illuminate on the dashboard, serving as an immediate indicator that the vehicle requires attention. Additionally, rough idling can occur, where the engine does not maintain a steady RPM, making the driving experience uncomfortable. A thorough understanding of these symptoms guides technicians in recognizing the urgency in addressing these DTCs. The first step in troubleshooting DTC P0171 is to start the engine and allow it to idle without any load, which ensures accurate readings of the vehicle's performance. Using the Honda Diagnostic System HDS, check the air-fuel feedback AF/FB parameter, focusing on its value during idle conditions. According to the diagnostic thresholds, if the AF/FB value exceeds 1.33, it indicates that the fuel trim value is too high, and this could point toward an underlying problem in the fuel system. In the event the AF/FB value is within normal ranges at idle, then the technician should proceed to conduct a thorough onboard snapshot procedure to gain additional diagnostic insights. In the second troubleshooting step, review the onboard snapshot to investigate the circumstances at which the AF/FB parameter was recorded at its highest value during the first step. Critical parameters include engine speed, vehicle speed, relative throttle position, TP, and accelerator pedal position, APP sensors. It's essential to drive the vehicle under the same conditions recorded in the snapshot to confirm whether the system still exhibits a high AF/FB value. While driving, again, examine the AF/FB parameter using the HDS. If the parameter fluctuates above the threshold of 1.33, this reinforces the concern about the engine running too lean at those conditions. If the parameter is normal, a further check should be conducted to explore other potential causes. Step 3 centers on ensuring that the MAF mass airflow sensor and IAT intake air temperature sensor are free of debris. Begin by turning off the vehicle to safely access these sensors located within the intake duct. Removing the MAF IAT sensor involves careful handling to avoid further damage. Inspect the sensor for any lint, bugs, or foreign materials that could obstruct airflow readings. If any debris is found, it's critical to remove it to maintain proper airflow measurements. Following the cleaning process, use a vacuum cleaner to remove any residual debris from the air cleaner housing before reinstallation of the sensor. A clean sensor is critical in ensuring accurate diagnostic readings as you proceed. Troubleshooting step 4 involves a visual inspection of all relevant components to ensure that there are no disconnected or damaged parts contributing to the DTC issues. Components to inspect include the crankcase breather hose, air cleaner housing, and intake air duct, along with the oil cap and dipstick. Any cracks or physical damage to these components may allow additional air to enter, exacerbating the lean condition. An effective inspection should offer a comprehensive view of how these components influence the air-fuel mixture. In cases where damage or disconnections are identified, necessary repairs should be implemented before proceeding for further checks, as this will clear potential physical roadblocks in addressing the DTCs. In the fifth troubleshooting step, the focus shifts to the EVAP, Evaporative Emission Control System, where inspection of the canister purge components is essential. This includes visually examining the non-return valves, both A and B, and the EVAP canister purge valve itself, along with the associated hoses. If any of these components are found to be disconnected or showing signs of damage, they may allow excessive air ingress into the system, compounding the lean condition. Conducting a thorough inspection is vital, as damage often goes unnoticed, but can severely affect vehicle emissions and performance. If any issues are identified, repair or replacement should be promptly taken to resolve the situation before moving on to further diagnostics. Step 6 involves checking the positive crankcase ventilation (PCV) system to ascertain its integrity. Continue letting the engine idle and gently pinch the PCV vacuum hose to see if there are any changes in readings that would indicate a vacuum leak. Using the HDS, monitor the AF/FB values during this test. If the AF/FB threshold remains above 1.33, it signals that the PCV system is functioning correctly and is not leaking. However, if the AF/FB value is within the acceptable range, further investigation into the vacuum hoses is necessary to identify any potential leaks leading to the lean conditions. effective management of the PCV system is crucial for the overall functionality of the engine's air-fuel mixture. In the 7th troubleshooting step, the aim is to identify any potential vacuum leaks in the intake manifold. Start by ensuring that the vehicle is off. Then disconnect the intake air duct from the air cleaner housing. The use of a large intake manifold adapter cone connected to the OTC LeakMaster Evaporative Emission System tester will allow for effective testing. By directing smoke into the intake manifold, visual inspection can reveal any areas where smoke escapes, which indicates leaks. Inspecting areas around the intake manifold, throttle body, intake ducting, and various vacuum hoses is essential for confirming leak presence. Any identified leaks should be repaired promptly, as they would compromise the air-fuel balance, leading to the DTC issues observed. Step 8 involves assessing the fuel pressure on the low side to confirm if it's operating within acceptable ranges when the AF/FB parameter exceeds 1.33. An insufficient pressure may indicate potential issues with the fuel supply system, such as the fuel pump or clogged fuel lines. Using the HDS, measure the fuel pressure during the same conditions recorded previously, ensuring the values meet specified ranges, essential for proper engine operation. If the pressure is not up to standard, it's crucial to check both the power supply and grounding for the fuel pump. If these are adequate, replacing the entire fuel tank unit may be warranted. Ensuring proper fuel pressure is pivotal, as low pressure could exacerbate the lean conditions indicated by the DTCs. In Step 9, the goal is to assess high fuel pressure levels following a series of necessary preliminary steps, including clearing the earlier DTC using the HDS. Once cleared, start the engine and maintain a consistent RPM of 3,000 without any load until the radiator fan activates, after which allow it to idle. By selecting the DI fuel pressure test from the HDS inspection menu, an accurate measurement of current fuel pressure can be obtained. If the displayed results fall within the normal range, you may then proceed to the next step. Conversely, observe abnormal readings that indicate high pressure. In this case, you will need to refer back to the earlier DTC troubleshooting for codes P0087 and P0088, which both relate to fuel systems and pressure. Step 10 focuses on checking the fuel injectors to verify their operational status. Start by ensuring the vehicle is off before transitioning to the on mode and clearing DTCs from the HDS. Keep in mind that conditions such as AC off and all electrical loads turned off create an ideal environment for testing the injectors. Execute the cylinder AF test 3 times. This test shows if any cylinders are failing to work properly. If a failure is indicated, replacing all injectors as a set is critical to restoring the system's functionality. If both pass or fail indicators do not appear, you may proceed to investigate other possible issues that could be causing the high AF/FB values, maintaining a logical workflow throughout the diagnostic process. In the 11th step, if the lean conditions arise shortly after refueling, it may indicate a fuel-related issue. Start by turning the vehicle off before draining the fuel tank completely. Refilling with known good fuel minimizes the risk of the problem persisting, and it's crucial to monitor the AF/FB readings while operating under conditions similar to when the issue was first detected. Once refueled, begin the engine and operate the vehicle to check if the AF/FB parameter remains within threshold limits. Should it show improvements, it indicates that the previous fuel was indeed the culprit, and sufficiently resolving this issue may narrow down the DTC aspects. If the AF/FB remains elevated, it would necessitate further investigation into other possible components affecting the fuel system. Step 12 centers on verifying the health of the MAF sensor by checking its readings under specific operational conditions. Start the engine and let it idle, ensuring that the engine coolant temperature is above 158 degrees Fahrenheit, 70 Celsius, and that it is in either park or neutral. Gradually hold the accelerator pedal to maintain 2,500 RPM for a full 30 seconds, while utilizing the HDS to check the MAF sensor's value. Proper values should range from 4.1 to 5.7 grams per second. Falling outside this specification indicates an issue with MAF sensor function. If the MAF readings are incorrect, it's essential to inspect surrounding components for damage before considering replacing the sensor itself. An effectively functioning MAF sensor is vital in ensuring that the air-fuel mixture is balanced for optimal engine performance. In the 13th step, if the MAF sensor appears to be working properly, the next logical component to check is the air-fuel AF sensor. To do this, first turn off the vehicle, replacing the existing sensor with a known good unit. Once replaced, start the engine and operate it under the same conditions where the initial AFFB values were monitored. After starting the vehicle, it's essential to check the AFFB parameter again while driving. If it exceeds the threshold, the original AF sensor may have been the source of the problem, validating that it requires replacement. Successful reinstallation and function of a new AF sensor should yield the correct mixture, thus resolving the previously observed DTC issues. The 14th and final step involves inspecting the fuel injectors again to ensure they are functioning correctly. If all previous troubleshooting steps have failed to resolve the high AFFB values, now is the time to replace the injectors with known good ones. Turn the vehicle off before making these changes and ensure that starting conditions remain consistent with previous tests. After installing the new injectors, start the engine and conduct a drive test under similar conditions previously monitored. Again, use the HDS to check if the AFFB values remain elevated. If so, this calls for a substitute of the Powertrain Control Module, PCM. Persistent high readings could indicate a deeper issue that requires thorough reevaluation of sensor inputs and mechanical issues within the fuel system. Upon completing all troubleshooting and repairs outlined for DTC P0171 and P2187, it's crucial to verify that all repairs were effective. Start by clearing any stored DTCs using the HDS, ensuring that the previously recurring codes no longer appear. Following the clearance, a test drive should be conducted under various driving conditions. This allows for a comprehensive understanding of whether the remedy effectively resolved the lean conditions. While monitoring system performance, pay attention to the vehicle's engine operation and check for any recurring alerts or symptoms. If the vehicle operates normally without triggering DTCs, this would indicate successful resolution of the issue. To prevent recurrence of DTC P0171 and P2187, proactive maintenance is essential. Regular inspection of sensors, especially the MAF and AF sensors, can help catch potential issues before they lead to trouble codes. Additionally, routinely changing the engine fuel and filters ensures that the system remains clean and free from particles that could lead to malfunction. Maintaining the integrity of the vacuum system is equally crucial, as leaks in hoses can introduce excess air into the intake manifold, leading towards lean conditions. By establishing a scheduled maintenance routine, vehicle longevity and performance can be significantly enhanced, thus minimizing downtime and repair costs in the long run. In conclusion, the troubleshooting of DTC P0171 and P2187 underscores the importance of systematic diagnostic procedures in identifying and resolving lean fuel conditions effectively. These diagnostics not only focus on immediate repairs, but also highlight the necessity for ongoing maintenance practices. Following the outlined steps ensures that each component, from sensors to fuel injectors, is thoroughly inspected for optimal operation. Understanding the root cause of lean conditions reinforces the critical need for a tailored approach to each vehicle system. Proper maintenance, including regular inspections and timely repairs, will emulate better performance and adjoin the overall longevity of the Honda CRV. Implementing these measures will not only enhance the driving experience, but also ensure compliance with emission standards. Please like and subscribe to the channel. See you next time.